let's look at this painted cube problem and some of the connections and the process you are generally, hopefully, going to encounter. You want to look at how many cubes are there and how many faces are there. This is a cube. This is its face. This is another face. This is another face. And then, so the main question is, how many faces get painted? And a lot of you discovered an answer to that, but the big deal is, how did you confirm that answer? How are you so certain that you are correct? And then, did you see a pattern and could you develop formulas? So here are some of the connections and discoveries I was hoping you guys would encounter. So to start, remember we have a red cube dipped in blue. And so you want to think, okay, how many cubes are there? I drew these cubes, make your lives easy, guys. Just on Notability, like draw a good looking cube so you have it to work with, and then you can copy it and paste it and copy it and paste it. So some of you guys looked at, all right, I'm going to just count, like here's a cube, there's a cube, there's a cube, there's a cube, and then I have that layer is 4, and then underneath I'll get another 4. Some of you looked at, well, it's a 2 by 2 cube, and then it's also a 2 by 2 by 2 by 2, so 2 cubed is 8. And you might have noticed immediately, oh, you just cube everything, so, because it's a cube. So you do length times width times height, and you would get the cube. So you figure out how many cubes there are, and then this is how many cubes you have in an n by n by n cube. Cool. All right, not rocket science. But then how many faces are there? So some of you guys wanted to start with a 2 by 2 cube. That's a great idea. And some of you guys went with a 3 by 3. What was helpful about the 3 by 3 was it actually included these edge cubes, right? That had 2 faces to them. And then here's another edge cube right here. Here's another edge cube. Here's another edge cube. Here's another edge cube. And keep in mind, this edge wraps around and there's another face underneath there. There's another face underneath there. Here, this edge wraps around and there's a face along the other side. This edge, there's another face on that same cube, in the same way that this has one face here and this edge cube, the same cube, has another face there. So, and then I have my corner faces, my corner cubes, and they have 3 faces. And you wanted to attend to the fact that corners have 3 faces exposed and 3 not. Edges have 2 faces exposed and painted and 4 not. And then you have these center pieces maybe, or face pieces, right, that just have 1 piece exposed. And then you talked about, oh wait, yeah, that's right, there's also a cube in the middle that doesn't have any faces that get painted. But before we look at all that, or maybe while we do, maybe that can be helpful. Maybe we can figure out how many faces there are. So what I'm going to do is count up how many faces there are on this side. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Sweet, so I get 9. And then how many big cube faces are there? Well, there's 6 faces. So why don't I just take 9, which is the amount on one single side, and multiply it by 6 sides. So I'd get 54. And let's go to 2 by 2. So I guess 2 by 2, I would take 4 and multiply it by 6 sides according to this sort of formula or process. So it should be 24, but let's just check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then there's a bottom, a back, and a side that I'm not seeing, so I should double it. Okay, that's 24. So both methods I'm doing, I feel like that's good. So I guess, what am I really doing here? Like, could I develop a formula? Like, how am I going to find a 4 by 4 cube? And some of you guys, right off the bat, it was awesome. Right off the bat, you're like, hey, wait a minute. You take n squared, which gives you one side of a cube, and then you multiply it by 6. Oh, cool. Yeah, logically, that makes sense. Now, some of you might have done all this data and then figured out, oh, this is the formula. And when I ask you to explain your formula and write the logic behind your formula, you should have thought, why is it 6 times n squared? What is n squared? Well, n squared is one side of a cube, and that captures all the faces on one side. And then you multiply that 6 by 6 because there's all these other faces hiding behind here. That makes sense. Now, how many get painted? Ah, wait, this whole time, I've only been talking about how many faces get painted. Well, how many total faces are there? I just talked about how many painted faces there are. Well, how am I supposed to figure out how many total faces there are? Well, logically speaking, how many cubes do I have? I have n cubed cubes. So the total number of faces, so this is going to be painted faces, and the total number of faces is going to be 6 times n cubed, because n cubed is how many, this is how many cubes there are in the whole thing. I decided that earlier. And so how many faces do they each have? Well, 6. Now, some of you guys might have figured out, after doing a lot of exploration, that the ratio of painted faces to the total number of faces, by the way, some of you guys didn't read directions, so you did like painted to non-painted, which got you a different fraction. But the ratio of painted to the total ended up being 1 over n. You just noticed, like, you did 2 by 2 and 3 by 3 and 4 by 4, and you figured out it was always like 1/3, 1/4, 1/5. But look here. Here's a way you could have confirmed that data, or you could have found it just by looking at this. If you take painted over total faces, when you simplify this, you get 1 over n. Ha-ha. So see how there are multiple ways of making these discoveries and confirming them? All right, so we talked about how many faces get painted. So I got this total of, let's go back to this total of 6n squared faces. And I'm going to just use this up here because I already drew on this cube. Oh, dear. So the total of painted faces. All right, I'm not sure if my total of 24 and 54 and what's 64 times 6? Let's see, wait, that's the number of painted faces. Yeah, wait, 16 times 6. So this will be 96. Like, I'm not sure if that's data's correct. So how do I confirm that? All right, well, let me break it down smaller. So I'm going to confirm it, right? That's a big question. Like, how do I confirm it? So I'm going to confirm that 6n squared get painted. Logically, yes, it makes sense, but because I mentioned to you, like, you should talk about corner cubes and you should talk about edge cubes. Well, guys, you should talk about them then. So I have these corner cubes. Now, how many? They have 3 faces painted and 3 not. And how many corner cubes do I have in a cube? You guys notice that you always have 8, which is cool. All of you guys figured that out. That's great. Now let's look at these edge cubes. So here's an edge cube, and it goes around the edge. Each edge cube gives you 2 faces painted and 4 not painted. And so the question is, how many edge cubes do I have? Let's just talk in a 3 by 3 cube. So I have, this cube, this cube, this cube, and this cube. This one, and this one, and this one, and this one, and this one. But then I have, like, another one back here, opposite to this one. So that's 1 extra. Another one opposite to this one. That's another extra. And then one of them back here on the vertical part. So that's another extra. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Does 12 make sense? Well, let's see. Oh, one way I could think of this is, like, when I draw a cube, how many edges do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I'm going to have 12 edges. Okay, so there are a total of 12 edges. is that in any cube? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that's in any cube. It's going to have 12 edges. Okay, cool. So, but how many edge cubes are there? Well, in a 3 by 3 by 3, I got 12. And in a 4 by 4 by 4, you're going to have 2 of these in each spot. And so some of you guys put it together that, look, anytime you have any number of cubes, you have to take away the corner here and the corner here, and the rest are edge in between. So this was n, and you took away 2 corners, n minus 2. This was n, and you took away this corner, you took away this corner, and the rest of these were edge, so n minus 2. So if you take 12 and you multiply it by n minus 2, that should give you the number of edge cubes. Wow, I'm developing a formula. Cool, I just got one. Now, maybe you just, does that work? Let me test that. Let me test that on a 3 by 3 by 3 cube, because I know I'm supposed to get 12. So 12 times 3 minus 2. Okay, cool, nice. All right, now the core cubes, a lot of you thought of like a walnut or an onion. Those are the cubes like hidden deep inside the center that you can't even see. They have 0 faces painted. 6 are not painted. Okay, and so the core cubes, you got to realize you take off the top layer, you take off the outside layer. So you're again doing an n minus 2. You're taking off the bottom layer. So again, it's an n minus 2. And maybe this just took you some time to visualize, and that's fine. Or just logically, like, okay, you have to take off these 2 parts and these 2 parts and this whole layer and this whole layer. And that takes like looking at a Rubik's cubes. But what you figured out was the core was n minus 2 cubed. Now, how many center cubes do I get? So those are these ones sitting here. And you could count these up and visualize it. So I have 1, 2, 3, and then on the opposite side, and underneath. So that's 6. So for a 3 by 3 by 3, I should get 6. But doesn't that make sense that I have 6 sides of a cube? And how could I calculate like what I get here? So if I had a 4 by 4 by 4, I would have this center of a 2 by 2. So 3 by 3 by 3 had a center of a 1 by 1 by 1 core. A 4 by 4 by 4 is going to have a core of a 2 by 2 by 2. So you're noticing there's this like minus 2 thing. Oh, yeah, that makes sense, because you subtract this and this, take away 2, subtract this, you take away 2. Okay, cool. So the number of core pieces, I'm going to have n minus 2. And how many faces of the cube do I have? 6. So that's the number of, centerpieces. I said core. That has 1 face painted and 5 not painted. So remember, I'm trying to confirm the fact that, let's say, a 4 by 4 by 4 has 96 faces that are painted. Logically, we confirm that should be n squared, but a 4 by 4 by 4 should be 96, so that's the question. Is that true? So let's see. The number of core cubes I would have that give me 0 faces painted and 6 not. So I would get a 2 by 2 by 2 cube, so I'll have 8 cubes. That's 0 painted and 48 not painted. For the center ones, I'll have 6 times 4 minus 2. So for the center ones, I'll have 12. Oh, don't I need a 2 squared here? Yeah, I do. Oops. Have you guys been waiting for me to figure that out? I'll have 12 times n minus 2. So in this case, it'd be 2, 4. Okay, so what am I doing? Oh, dear. So I'll have 6 times, what's 4 minus 2? That's 2 squared, so 6 times 4. So I'll have 24 cubes remember, specifying between cubes and faces. So one face painted, that's 24 painted, and 5 times 24, 120 not painted. Okay, the corners, I'm always going to have 24 painted and 24 not painted. That's so great. Love that. Now the edge pieces, I'm going to do 12 times 4 minus 2. And so I'd have 24 painted and 4 times 24. So hold on, sorry. 24 edge cubes. And then I'll have 20, those are 2 faces. So that gives me 48 faces that are painted. And then 4 times 24, I'll get 96 faces that aren't painted. So if I'm trying to confirm that 96 faces are painted in a 4x4x4, I add up 0, 24, 24, and 48, and I get 96. Sweet. So not only have I confirmed this 6n to the squared painted faces, but I've also answered the problems, which was looking at core, center, corner, and edge pieces. And I've developed all of these formulas, which are kind of cool. So here's a cool connection. There's different ways to do this. When you're counting cubes, right, you have 12, remember we have 12 edges when we draw this cube. And when you're trying to figure out the number of edge cubes, okay, so this is our goal. Let's pretend we're figuring out the number of edge cubes, so the number of cubes that like go around and then around the corner, right? So you could think of that as, okay, look, there's n minus 2 on every edge of the big cube. So you take n minus 2 and multiply it by 12. So that gives you 12n minus 24 cubes that are edge cubes. And so how many faces does that produce? Well, 2 times that, because you have 2 faces that get painted. So we have 24n minus 48. Or I could factor that out and get 24n minus 2. All right, so that's the number of edge faces that I get. Now let's approach this by just counting faces. So we're going to do this differently. Up here I focused on edges, that there are 12 edges in a cube. And I thought, well, how many edge cubes are on each of those edges? Now I'm going to think, let's just look at these cubes like face on. So if I have a 3x3, I see I have 4 edge cubes. If I have a 4x4, I see I have these edge. Now, those aren't like, do I want to count those as cubes or faces? Let's just count those as faces, because I don't want to deal with the fact that there's like also this face over here, and then I'm going to worry about recounting. So if I just say like, look, this has 4 edge cubes, edge faces on 6 sides, wouldn't that give me 24 edge faces? And this is 2, 4, 6, 8. This is 8 faces on 6 sides, so that should give me 48 faces that are exposed, that get painted. And so how do I figure out the number on each big face or side of the cube? Well, I just take n minus 2. And then I multiply that n minus 2. But let's see, does this give me n minus 2? But I take n minus 2. But oh wait, there's an n minus 2, yeah, but then I have to multiply it by 4, because look, there's 4 sides. So 4 times n minus 2. But then I have to remember that there's 6 sides of the whole cube. So look, don't I get 24 times n minus 2, which is what I got up here. Cool, that's great. Now let's look at this as layers. So some guys liked to divide things into layers. And they're like, look, this has a layer, this has a layer. So each layer has 4 edge cubes. Like here's an edge cube, here's an edge cube, here's an edge cube, right? And then this last layer, again, would have this edge cube. No, this is going to be a face cube. Never mind. Is going to have this edge cube, this edge cube. So would this, oh, this layer is going to have this as its edge cube. So again, 4. Okay. So if they all have 4 and there's 3 layers, that means there's 12 edge cubes in a 3 by 3 by 3. How should I have known that? Well, n minus 2, and each layer had 4 of them. And then I had 3 layers. So 12 times n minus 2 edge cubes. And then so if they each give 2 faces, don't I get 24 times n minus 2 yet again? So I've now shown that in 3 different ways how you can get 24 n minus 2. So I'm confirming my data. So here's a cool connection. This is the total number of faces. This is the total number of painted faces. So, shouldn't, when you go back up here and you add up all of these formulas for the number of faces painted, so this would be 0 faces painted get there. This is the number of centerpieces. You just multiply that by 1. This is always 8. When you add this up, do you get 6n cubed minus n squared? No, because I'm trying to find the number that are unpainted. So when I add all that up there, that should give me this. So if I go up here and I look at the numbers that are not painted, and if I multiply these parts by that, shouldn't it add up to 6n cubed minus 6n squared? Show me that algebra.